Hey guys, this is Mr. C, and today we're going to look at evaluating some algebraic expressions. And so I picked out some problems here that look a lot like the ones you'll see in your Algebra 1 course, possibly Algebra 2 maybe. And then you'll see them on the ACT. If you take the PERT, you'll see them on the PERT, and the SAT, and all those other usually standardized tests that you will be taking at some point in time. So here's what you do. This one, the expression can look like anything really. And so doing examples of these, the next one you get is going to be different. All right, so we're just going to kind of see what skills are necessary for you guys to be able to do this correctly. So what happens is it says simplify the expression below where x equals -2 and y equals 3. So we have two variables, x and y, and they give you the values of both of them. And so basically what you're doing is you're plugging things in and then you're going to simplify. So x is -2, and what I can do here is I can actually just use some different colors. So we got a -2 going in for that x. We've got a -2 going in for that x. Okay, and then y is 3, and so we're going to get a 3 going in for the y's here. 3 there, and then 3 here. And then we're just basically going to use the order of operations and simplifying techniques to get this down to one final answer. All right, so here's what we got. We got -2. I'll keep the parentheses for now. -2. I don't need parentheses around the -2 because it's all by itself. There's nothing in front. So plus, and let's do this. 3 times 2 is 6. Save myself a little step there. Minus 3 times -2, and that's -6, minus 3. Okay, so everything looks good where I plugged it in. And so now all we're gonna have to do is start simplifying this. So in the parentheses now, you can't really subtract anything yet. -2 plus 6, that would equal 4. So we basically have 4 minus -6 take away 3 would be -9. And since that's negative here, I'm about to subtract a negative. I don't like to do 2 steps in one, so I'm gonna keep the parentheses here around the -9. Because if I don't, I'm going to get one of the other choices or I'm just going to get it wrong. All right, so now let's see what this looks like. 4 minus -9, 2 negatives make a positive, right? We've all seen that. 2 negatives make a positive when they're side by side. So we have 4 plus 9, and then we all have to agree on 13 as our final answer. And so in class, I would give a problem like this, and I'd see probably 4, 5, or 6 or more different answers than 13. And so just got to be careful and use the order of operations correctly, and we should arrive at the correct answer. So 13 was it. Okay, here we have A is 2 and B is 4. So I'm going to do the same thing I did before. I'm going to use different colors here. A is 2, B is 4, and we'll use red for that. Color, whenever you can use it, helps tremendously. All right, so now we're going to get 2 squared, well 2 squared is 4, I can do that right away. Minus 4 squared is 16, and then we need to square that. So we don't want to distribute the 2 to these, that's not what we want to do at all. What we want to do is just do 4 take away 16, and 4 take away 16 should give us a -12. And that is still squared on the outside. Remember, order of operations, you have to do parentheses before you do exponents almost always, but not every time. In this case, you do have to do it that way. And then -12 times another -12 should give us a positive 144. All right, and that's a pretty popular one, especially on the PERT. Let's take a look at this one. Okay, this one, we have m is equal to 6 and n is 5. So now, wherever I see an m, let's throw a 6 in there. Okay, wherever I see an n, we're going to put a 5 in there and see what happens. So let's put a 5 right there and a 5 right here. All right, so now let's simplify. So we got a 6 on the outside of these brackets, which are basically just grouping symbols. So we have a 6 here, and then we got our bracket. We can do 6 take away 5 easily. That's just going to be 1. And it's in parentheses, but there's nothing out front here but a 1. So we might as well just write 1 there. 1 minus, we could do 4 times 5 here, and that's 20. That's no problem. Okay, so now we have 6 times 1 minus 20. And so that's going to be equal to 6 times. And the cool thing about grouping symbols is even though those are brackets, I can substitute parentheses in for those if I want to. 1 take away 20 is negative 19. Okay, so now all we have to do is 19 times 6, and then we have to take the negative of it. And if you have a calculator, then you're going to get negative 114. And then that should be it for that one. All right, let's take a look at this one now. Again, I'm giving you a wide variety of these problems, just so you see. So this one, let's do b is negative 1. Use green there. And we've got c is negative 3. And so why do we use negatives a lot? Because that's exactly where people get tripped up. And so you just have to expect the negatives to be more common usually than positives. So we have negative 2 on the outside of these absolute value bars. 4 times negative 1 is negative 4. Then we got a plus 2 times negative 3. That's going to give me a negative 6. So this whole thing is actually going to be negative 6 or minus 6 right there. Now, if you want to do that in 2 steps, if you want to do the plus minus, you can, but it's eventually going to be negative 6 right there anyway. So now we have negative 2, absolute value of, negative 4 take away 6 is even more negative, negative 10. Okay, now the absolute value of negative 10 is positive 10. So now we have negative 2 times 10, and now I'm going to use parentheses because I evaluated the absolute value and that the bars are no longer there anymore because I already did that operation. So negative 2 times 10 would be negative 20. All right, let's take a look at this one. Okay, so here we have a rational expression. So we've got, let's see, p is 7. So put that there and put that there. Okay, q is negative 5. And negative 5 there. Let's take a look and see how this is going to shake out. So it looks like, let me go over here real quick to the side. 7 squared is 49. Okay, and then we're going to have minus negative 5 squared. Well, negative 5 squared is a positive 25, isn't it? So what we're going to eventually get is 49 minus a positive 25. And all of that is over 7 plus negative 5. Now, you could write it like this if you want to. That's fine. 49 take away 25 is 24. 7 plus a negative 5 is going to give you a positive 2, right? Because remember, when the signs are different, you take the difference of the two numbers, and then you keep the sign of the bigger one. That's how they're supposed to teach you that in like 6th and 7th grade with negative numbers. So 7 plus negative 5 is going to be a positive 2. And you can think about it this way. If you have a running back that goes 7 yards, but then has to go back 5 yards, he really only gained 2 yards. And so whenever you relate negatives and positives with money or sports or something, that will help you calculate these without having to use a calculator. All right, so here we are down here. 24 divided by 2 is 12. And then that's our final answer for that one. All right, here we have another rational. This time we've got a fraction. That's no big deal. So we have 1/2 for x. And I'm trying real hard not to use a calculator because I really don't like to use calculators if I don't need to. If you use them too much, it kind of starts to dull your abilities. Y is 2. Okay, so let's see how this one shakes out. We have 1/2 plus 2 over 1/2. All right, that is what we call a complex fraction because you have fractions inside of a bigger fraction. To simplify a complex fraction, one of the easiest things to do, and I'll do it here in case you've never seen it before, is to multiply every term in this whole thing by the denominator, the least common denominator of the whole thing. The least common denominator of these three numbers is 2. If you multiply all of these by 2, like this, watch what happens. Okay, so if you multiply them all by 2, you're going to get 2 times 1/2. And you could do that because you can take the 2's away and it doesn't change it. It's really just equal to 1. 2 times 1/2 is 1. 2 times 2 is 4. Over 2 times 1/2 is 1. And so really what we have is 5 over 1, which is actually just equal to 5. So you see how this process makes things a lot easier, and then you don't have to worry about dividing fractions and adding them and subtracting them and all that stuff. So I'm going to try and do this every time that I can. All right, so here we have a is -2. So -2, -2. B is 1/3, 1/3, and 1/3. All right, so here we go. We plug everything in. -2 squared is +4 plus 1/3 squared is going to be 1 over 9, right? Because 1/3 times 1/3 is 1/9. So 1 over 9. All of that over -2 squared again is +4 minus 1/3 squared is again 1 over 9. So now I'm looking at this, I'm thinking, what is the least common denominator of all of these terms? Well, I see a 9 here and a 9 here. I can multiply everything there by 9. Okay, so let's try that. 9, 9, 9 there, and 9 there. And you just have to make sure to multiply everything by the same number. If you don't believe me, try and do it the other way with adding and subtracting the fractions. You're going to get the same answer. This way is quicker though. 9 times 4 is 36, plus 1/9 times 9 is 1, goes away. Again, 36, minus 1 again. And so now we're looking at 36 plus 1 is 37, and 36 take away 1 is 35. And then those two numbers have nothing in common. 37 is prime anyway, so you can't really do anything with that, and that's your final answer. All right, here we have a square root. So let's take a look at this one. Let's go back to our colors again. This time we have m is 1/3, and we have n is 1/4. So let's take a look at that. All right, so how is this going to shake out? Let's see. We're going to get the square root of 1/3 squared is 1/9 plus 1/4 squared is 1 over 16. And all of that is under the square root. All right, so now how do we simplify this? Let's go back to our butterfly method. That seems to be the easiest. To use the butterfly method, we do 16 times 1 plus 9 times 1 over 16 times 9. So what's 16 times 9? And that's going to be 144, right? Times 9, and it's 144. And we will take a look at this guy. 16 plus 9 is 25 over 144. Okay, now as we saw in our square root video, we can split this up into the square root of 25 over the square root of 144. And by the way, every professor and teacher is going to want you to do this. It's not optional. Root 25 is 5. Root 144 is 12. And then 5 over 12 is your final answer. All right, so not a big deal, even though it had two fractions in it. All right, so how much more complicated can this be? Well, it can get a lot more complicated because people can keep giving you expressions that are larger and larger with exponents. So let's just see how we can handle this. P is -3. So there, right there, right there. All right. And Q is 2. Well, at least I gave you one positive number. Q is 2, 2, and 2. All right, so let's see how this is going to shake out. All right, in the first one, don't want to do too much at once here. We got -3 plus 2 squared minus, okay, -3 minus 2, and that's not squared, plus -3 squared, well, we know that that's going to be 9, plus 2 squared is 4. All right, let's simplify it one more time. So now we've got negative 3 plus 2 is negative 1 squared minus negative 3 take away 2 is negative 5. And then 9 plus 4 is 13. We can just add that on to the end. All right, one more step here. Let's see what we got. Negative 1 squared is 1. Minus negative 5 would be plus 5. Plus 13. Okay, 5 plus 1 is 6. Plus 13. And then we all have to agree on 6 plus 13 is 19 as our final answer for that one. All right. Here's one with a couple different things. Now we have 3 different numbers to plug in. So let's see how this works. A is 2. Okay, so I gotta save a little bit of room here. B is 3. And if you know me from the classroom, you know this is what I would be doing. I would be actually showing the numbers going in. Negative 1 here, and then negative 1 there. All right, let's see if we can break this down over here. So let's go ahead and draw a little fraction bar there. 2 squared is 4, plus 3 squared is 9, minus negative 1 squared is 1, so it's still going to be minus 1. Now, a lot of students are going to put a plus right there. That's a common mistake because they're going to think that these cancel out, when in fact you have to square the negative 1 first, then apply this minus after it. Okay, down here we've got 2 times 3 is 6, times negative 1 is negative 6. Okay, 9 plus 4 is 13, take away 1 is 12. And then I believe 12 divided by negative 6 is just going to reduce down to negative 2 for that whole thing. That's a real common PERT and ACT problem. Okay, that's a blooper. Here we go. All right, oh, fraction time. All right, R is 4/3. Okay, this is probably where some people cut out of my video because they see some fractions, but we're not going to do that. We're not going to shy away from it. S is negative 2. And T is positive 2. All right. Let's get everything plugged in there. Okay, here we go. 4 times 2 is 8. Minus, keep our bracket for now. 6 times negative 2 is negative 12. Minus 3 times 4/3. Well, 3 times 4/3, I believe the 2 3's are going to cancel, and that should just be equal to 4, right? So minus 4 here, close my brackets. So now we have 8 minus, negative 12 minus 4 is actually negative 16. And notice how I went from brackets to parentheses. That's completely allowed. You can do that, no problem. 2 negatives side by side make a positive. So 8 plus 16, and 8 plus 16 should be 24. And so that should be it. Doesn't look very complicated, but I can't tell you how many different answers I would get in the classroom if we just did this and, you know, people weren't completely paying attention or they're doing the order of operations wrong. It happens all the time. So just kind of make sure you're paying attention to what you're doing. Okay, so here we have one with a couple things. All right, so let's do this time. A is 3/4. Save some time, I'm not going to circle them this time. Okay, B is negative 8. And here. And we've got C is negative 1/2. All right, let's take this one kind of slow here, guys. 3/4 times negative 8. What is 3/4 times negative 8? Okay, 8 times 3 is 24. Divided by 4 would be 6, right? So all of this would be negative 6. Okay, I'm going to put a plus there. Now we have negative 8 times negative 1/2. Well, really what that is half of 8, which is 4. And the two negatives cancel each other out. And so this guy is just going to be a positive 4. Okay, let's keep that minus right there. Now let's do 3/4 times negative 1/2. Okay, to me that looks like it's going to be 3, because you multiply across, right? 3/8, and it's negative. Okay, so let's take a look at that. So if I left it like that, am I in good shape? Well, I don't know, because if I leave it like that, then there's a negative here, but there's also a negative here. These two negatives are going to cancel out, which means that should really be a plus right there. So I got to be careful with that. Now I'm looking at all three of these numbers. It might help to go ahead and combine these two together first. You got -2 plus 3/8. Okay, so how do you add 3/8 and -2? One way to do it is to treat this like a mixed number. 8 times -2 is -16, plus 3 would be -13/8. So I'm thinking -13/8 in my mind. Let's write that over here, -13/8. Possibly? Well, let's find out. Let's take 2 and let's go ahead and rename that. That would be -16/8 plus 3/8. How did I get -16? I just multiplied these two numbers together, which is kind of the same thing you do when you turn a mixed number into an improper fraction. So -16 plus 3, there's my -13, and there's my 8 right there. So now I know that I was correct and I'm good to go. All right, let's take a look at this one. Here we have 3 variables, one of which is an exponent. We can handle that. P is -2. Let's see, kept that. Okay, Q is 4. And then R is our exponent, and that guy is going to be 3 right here. This is, again, very common on the PERT or the ACT. All right, -2 cubed. Do we know what that is? -2 times -2 times another -2 is going to be -8. Okay, plus 4 squared is 16. And all of that is being cubed because that's where R is. So -8 plus 16 is going to give me a +8. So now we're looking at 8 cubed. So we're looking at 8 times 8 times 8, right? Okay, so that should give us 512. 8 to the 3rd power, and that should give us 512. So yeah, that's no problem right there. So 512 for that whole thing. Okay, now we have a problem where it's a quadratic expression and you have to plug a number in for x, which is very typical when you have a table of values and the teacher says to graph this function and you don't know how to graph it, right? I mean, it's complicated looking. And then you just have to start plugging numbers in for x. And so this is how you have to do it. So you put a -2 in there. You put a -2 in there. Okay, now we simplify. We got 6 times -2 squared is 4 minus. Okay, now we have 11 times -2. Well, that's going to be -22. But there's another negative right there, which means this should be a +22 plus 9. 6 times 4 is 24 plus 22 plus 9. Okay, 24 and 22 should make 46 plus 9. And 46 plus 9, well, 46 plus 10 is 56, but 9 is 1 less, so it should be 55 for that. So that whole expression should give you 55. Now, if you're graphing this at -2, it's way too big. You wouldn't be able to graph it on a normal piece of graph paper. And so that value right there probably wouldn't do you a whole lot of good. You'd have to start getting some other numbers that were a little closer to being small, so you can graph them on a piece of graph paper. But anyway, that's how you would you'd plug that in. All right, so let's take a look at this one, another quadratic, but this one's in vertex form. So this time we have a -7 for x. Okay, so we have -3 times -7 plus 5 squared with a -4 at the end. Okay, so we have -3 times. -7 plus 5 is -2 squared minus 4. So now we have -3 times -2 squared is +4. Don't do this times this before you do that squaring part, or you're going to get it wrong, and students do that all the time. They'll distribute this in there, and I always tell them not to do it, and there's going to be a few that are still going to do it, and then kind of be sad when they get their work back, but that's just how it is. You just have to learn. And then you have a -4 at the end. So now we have a -12 -4, and that should give us -16. All right. Let's take a look at this one. A couple more to go. All right, so we got 3 variables here. Let's use some color, or actually 2 variables. I'm sorry, A and B. A is 3. And B is 2. Let's take a look at that. 2 there. 2 there. All right. Simplify a little bit. We got 3 times 2 is 6 to the 2nd power minus -3 times 2 is -6 to the 3rd power. All right, so let's simplify that. 6 squared is 36 minus 6 cubed is 216, and it's going to still be negative because when you raise a negative to an odd exponent, it's going to retain the negative. So it's still going to be -216. So now we have 36, take away 216, and that should give us -180. So our final answer should be -180 for that one. And finally, our last example, save the best for last. Got 2 variables in here, A and B, but it looks kind of complicated. Let's see how this is going to work. All right, so we got A is -5. If you knew something about quadratics, you could simplify this easily, but we're going to assume you don't. -5 for that A, and -5 for that A. Okay, now let's do B is 4. 4. And 4. All right, so let's see what we got here. Let's cap that marker. All right, over here on the side, -5 squared, +25. -5 times 4 is -20, times 2 would be -40, and 4 squared is 16. All over, -5 squared is +25, minus 4 squared is 16. All right, here we go. We got 25 to take away 40 first. We have to do that. That's going to be a -15 plus 16 over, and then 25 take away 16 should be 9. -15 and 16 make just 1. And so our answer should just be 1/9. All right, guys, this was simplifying, or evaluating some algebraic expressions. So remember to like and share, subscribe to my channel, and we will see you guys later. Bye.